This video covers simplifying algebraic expressions. We can simplify algebraic expressions by replacing the original expression with a simpler equivalent expression. To simplify an expression, we use the associative, commutative, and distributive properties. In these examples, we're going to list our property after using them. Our first example is 6 times the quantity 5y. So our associative property, I'll abbreviate that as associative property, tells us that we can multiply these in a different order. So instead of saying 6 times 5y, we can say 6 times 5 multiplied by y. Sometimes getting the variable by itself makes it a little easier to see. So we know that 6 times 5 will give you 30, and the y stays attached on the outside. 30y is your solution to that problem. For our next problem, we have the quantity 5y multiplied by 6. Our commutative property tells us that we can multiply these in any order. So our associative property says that you can multiplying 6 times 5 is the same as multiplying 5 times 6. Our commutative property says that any multiplication in any order will give you the same answer. So we're going to rearrange this as 6 multiplied by 5y, and then we can regroup because that's also part of the property. So we can say 6 multiplied by 5 times y, and we have the same thing as above, so we get 30y. In our last example, we have 6y plus 9y. We're going to use the distributive property. Remember that the distributive property has a couple of different ways that it can present itself. One of those is if you have a number a on the outside and 2 on the inside, you can distribute that first number on the outside to the other two. So you can have a, b, paying attention to the sign in the middle, plus a, c. You can also do the distributive property in reverse when you realize that two terms have the same variable in it. That means you can factor it out, so we can pull the a outside of the parentheses and have b plus c in the center. So you're pulling this a out and this a out, putting it on the outside because you know that you would distribute it anyways. And then you have the other piece, this b and c, on the inside. This is identical to our first expression, so we know that all of these are equivalent. So to use our distributive property for this problem over here, we notice that y is a common factor. So we pull out the y and have 6 plus 9. So you have 6 here and 9 here. Pulling out our y's, and remember you would just distribute these if you were going the other way, which would give you your original expression of 6y plus 9y. So we have y on the outside, we do 6 plus 9, which is 15. And now we simply multiply, because parentheses next to a variable means multiply, so you have 15y. Using the distributive property in this way is extremely common. All of the numbers or quantities being added or subtracted are known as terms. So I'll write that. Our word is terms. Just like in these small simplifications, we can use all of these properties on more complicated problems. In these two examples, we'll simplify by combining like terms. Our first step is to reorder the terms so that you have like terms together. That means that you want to take all terms with similar factors, such as these terms with a, and these terms without a, and you want to group similar terms together. You can do that because you can turn all of this into addition, so you can turn this into a plus, negative, and you can use the commutative and associative properties to reorder your work. So let's give this a try. Step 1, reorder the terms. I'm going to say reorder or collect the terms because you're putting like terms together. So I'm going to say 7a plus negative 4a. So these terms both have a, so we're putting them together, and we can just tack the other two on the end, plus 9 plus 5. Step 2 is to combine like terms. When we combine like terms, we want to take similar expressions like these ones with A's and these without A's, and we want to make one term for each type. So this one, over here, we can pull out an A because it's a common factor using our distributive property, and then we have 7 plus negative 4. So this is just our distributive property. If you're confused by this step, rewatch the example on the last page. So we're just pulling out our common factor and then putting our numbers in parentheses. And then we can add 9 plus 5, which will be 14. For our last simplification, we'll do this part here. So 7 plus negative 4 would give you 3. Multiply that by a number on the outside, which is A, plus 14. You cannot combine these terms any farther because one of them has an A and the other one does not. You also may have noticed that in this step, I went ahead, or actually I guess it's this step here, I did the addition here before taking care of all of this. Because the whole problem ends up being an addition problem, like the original problem is addition, it doesn't matter what order I add them in. If you find this confusing, I suggest you still follow PEMDAS. For our second problem, we're going to do the same thing. This one has some more negatives. I'm going to do the same thing where I turn them all into plus negative instead of minus. That way I know I can use my commutative and associative property to move numbers around. So our first step is to reorder and collect the terms. So these terms are actually pretty well together. So we have 15x plus 3x, and we have 2 plus 5. So our second step is to combine like terms. So now we want to combine these, so we'll say x is on the outside, that's a common factor, 15 plus negative 3 plus 2 plus 5. So 15 plus negative 3 will give you 12, that's multiplied by this x here, plus 2 plus 5, which is 7, and your final answer is 12x plus 7.